Good morning and welcome to Statistics, Monday 427. And today we're going to do part 2 of hypothesis tests for a population proportion. Now let me take you right to where we left off. And right here, review question. A politician wants to know if a majority, more than half of her constituents, are in favor of the new tax bill. The hypothesis test, therefore, would be as follows. Here's her null. Okay, the null of the proportion being equal to 50%. And then she wants to have an alternative that the proportion is greater than 50%. So she's starting with the assumption, a null hypothesis, that only half of the voters are in favor of this tax bill. She'll conduct a poll and compare her results to this assumption. And this is what it revealed. Her poll reveals that out of 1,000 registered voters, 534 are in favor of the tax bill. Now this gives her a point estimate, 534 divided by 1,000 of 0.534. Okay, so that is more than half, but now we ask, can she safely conclude that the majority of voters in her district approve the bill? So that's why she's asking, did I just happen to poll people who were mostly in favor of the tax bill, or would these results be typical if I were to repeat this poll over and over? Well, yesterday we did what's called the classical approach, where we drew the pictures and everything, but today we're going to do the p-value approach. Okay, so turn your calculators on and hit the stat button and scroll over to tests. Then scroll down to number 5, which says one prop z-test, and hit enter. Now just hold that thought for a minute. For PO, you're going to put in 0.5. See, that's the proportion that we're assuming. That's the null hypothesis. We're assuming that 50% are in favor of the tax bill. Now be careful on X. I have it highlighted in blue so you don't make the mistake that I made yesterday. It's 534. That's how many out of 1,000 she got in her poll, okay? So you're putting in the actual number, not the decimal. So put in 534 for X, 1,000 for N, and then for this next part, okay, it says prop, and there's 3 selections. So scroll down to the one that says greater than PO and hit enter. Now, the reason we choose that is because she wants to know if more than half of the population approves the bill. If more than half does, then your null is half, and then she got more than half. She wants to see if it's going to be greater than that 50%. All right, highlight, calculate, and hit enter. Now, when you do, you should see some numbers there. You should see a z-score in your screen that says 2.1503488. All right, I rounded it to 2 places simply because that's how the z-scores are in table 5 in your book, okay? Now, this alone tells us to reject H sub O. If you're saying, how do you know that alone tells us to do that? Because remember what you guys are always telling me, all right? If your mean is 0.5, okay, and you end up getting 0.534, okay, 534 out of 1,000, okay. If you could convert that to a 0, then this score would be 2.15, which means the 534, the 0.534, is more than 2 standard deviations, okay, above the mean. So if the z-score is, greater than 2, you're going to reject the null hypothesis that 50% are in favor of the bill. All right, but also look at this. There's also a p-value in there, which says 0.158. Well, that means that the probability of getting 0.534 when you have a 50% assumption is a very small probability. It's only filling up 0.158, or about 1.6% of the area under the curve, okay, like that. All right, so it tells us that the probability of getting 534 out of 1,000 when the actual population proportion is only 0.5 is only 1.5%. Again, not very likely of happening. Remember the rule of thumb, if it's less than 5%, and that's just a rule of thumb, okay? So don't hold that as a always true, but like, generally we say if it's less than 5%, it's not likely. For your notes, please pause the video. Okay, p-value is the probability of a sample. Now, what do we mean by that? Well, her sample was 0.534. Okay, in the obtained result in the obtained statistic. So, in other words, 0.534 resulted in a statistic of 0.158. Only 1.6% of the time will you survey 1,000 people and get 534 of them. All right. And that's only if the null hypothesis is true, if it's true in this case that 50% are in favor of this. All right, let's repeat the procedure for attaining the p-value, only this time you highlight draw. So go back to stat, go back over to tests, go back down to number 5, hit enter, but just arrow down this time because your information should be the same unless you deleted it all. And instead of highlighting calculate, highlight draw and hit enter. And look what it draws for you. It draws for you a nice bell curve, okay, so that you can visually see what it's looking at. Look, and it's what it looks like right there. So what it's saying, again, is that at 2.15, there's the z-score, that's going to be about 1.6% of the area under the curve, and 2.15 is where 534 would be if indeed you had a mean of 0.5. An official with a certain U.S. state wonders if less than half of the state's high school seniors are prepared for college mathematics. She wants to know if less than half of them. So she wants her P to be less than 0.5. Less than half. She wants to know if less than half of the states are state seniors. Okay. She gathers the records of 500 random students who took the ACT. She discovers that 219 of them, so 219 out of 500. Divide that in your calculator. Let's get a point estimate for that. 219 divided by 500. 0.438. So it is less. It's less than 0.5, which would be 0.500 if you, added some more zeros. So yeah, it is less, but does that mean she can safely say it's yes is the question. Okay. Of the 219 scored a 22 or higher on the math portion of it. That's the score used to determine college readiness. So less than half of her sample is college ready. Does this data represent evidence that less than half of the students in her state are prepared for college math after high school? Use alpha equaling 0.05 for your level of significance. Now, we're going to talk about that later. Right now, we're going to look at the solution, and we're going to do it two ways. We're going to do the classical way and the p-value way. The classical way was the way we did in the previous lesson. So doing the classical way, put your information into this right here, all right? Your P sub O, same as the mean P sub O, is 0.5. Her sample's 500. We're assuming this right here. She did it for her state. 500 students would certainly be less than all the students in probably any given state. Okay, so we're okay with that one. But take a minute and prove this one here. By the way, it says P, but that's a generic P. So in this case, it's 500 times your 0.5 again. Okay, your 0.5 times your 1 minus 0.5. That should be greater than or equal to 10. Pause the video, figure out the standard deviation, and figure out this. Okay, your standard deviation should be 0.0224. If you didn't get that, just email me, but all you had to do was put in 0.5 there, 0.5 there, and 500 there, and do the square root. And then this is coming out to 125, which is indeed 10. Calculate the z-score now based on that. Now, I only have the z-score twice because it might be written differently in the book, but it's following this kind of idea right here, okay? It's what we did before. We had before x minus the mean divided by the standard deviation. Well, your x is your point estimate this time. and then your mean is your mean for that assumed population, all right? And we already knew that was 0.5, MPO is the 0.5, and then the point estimate's 0.38. This we just calculated, okay? You got 0.0224. All right, so put all that into your calculator. This is saying the same thing, okay, down here. It's just that this is how it look on some homework questions. They might write it like that, but it's the same idea. All right, so figure out, if you would please, the z-score. Pause the video. Okay. You should have had 0.438 minus 0.5, okay, and divided by 0.022. Now, I didn't round it to 4 down here, but I would, okay. But even not rounding, I think your answer said negative 2.76 with some decimal that would have rounded it up. I've already done this, so I know. So you should have got negative 2.77. Now, before we go on, okay, let me just keep explaining what this means to you. All right, please, you don't want to just do this stuff and say, okay, I got numbers, I'm done. No, it's saying that if the mean is 0.5, okay, if that's what the mean score is, and again, going right there, okay, then 0.438 is about 3 standard deviations away. Now, I'm not going to go right to 3 because what is it? It's negative 2.77. So right there is where 438 would show up. It'd show up somewhere right there. More than 2, right? So that should tell you to reject it because like you guys say, if something is more than 2 standard deviations away from the mean, it's an unusual result. So the 438 is an unusual result. That means that it must not be true that half of the students are college ready. All right, now let's go ahead and verify this in our TI. So hit stat, go to tests, go to number 5. Okay, once again, your P sub 0 is going to be 0.5. She's comparing 0.5 with her 438, but we don't put in 438. She got an X value of 219. She got an N value of 500. All right, that's all she surveyed this time. So change your X value to 219, change your N to 500, and this time your prop, okay, set it for less than P sub O. Okay, so over to less than P sub O and hit enter. And now go to calculate, hit enter, and you should see a z-score of negative 2.77. You should also see a p-value of 0.002. I'll round it to 0.003. In other words, about 0.3%. You got to realize what 0.3% is. That's less than 1%. So 1, 2 right there if you move the decimal. The probability of getting 0.438 or 219 out of 500 when the assumed mean is 50%, the probability of that happening is less than 1%. So we would shade that in and say that's an area that's just, about, 0.3% is all that is, where 438 is. All right, we didn't discuss this earlier, but with a critical value of alpha equaling 0.05, okay, we are only interested in knowing if our z-score lies in the region left of negative 1.645 standard deviations from the assumed mean of 0.5. All right, I told you we were going to talk about the 0.05 later. Well, now it's later, okay? Here's your mean, okay? If your mean is 0.5, and if I convert it to a mean of 0, okay, that's what the z-score does, where would negative 1.65 be? Negative 1.645 right there approximately. Okay, now negative 277 is obviously to the left of that, okay? Negative 2.77. So that's what we're saying. We're saying that we're only interested in knowing if the z-score lies in the region left of that, which it does, okay? And that's assuming you've got a mean of 0.5. So we go ahead and we reject it, okay? Because it lies left of the negative 1.65, we reject that idea that the mean is 0.5. So without an established critical region, you go with your less than negative 2 standard deviations. That's what you guys are always saying. If it's more than 2 standard deviations, then you reject it. That's fine. But if we give you a critical value, or if you give you an alpha, or established critical region, I should say, if we give you an alpha of 0.05, then you're just saying, is my negative 2.77 or whatever my z-score is it less than negative 1.645? Now, some of you are saying, how did he get negative 1.645? That's table 5 in the back of your book, okay? Go to table 5 in the back of your book, and at the bottom, you'll see another chart that says hypothesis testing critical value. If your level of significance is negative point or is 0.05, level of significance 0.05, that's what it said earlier, then a left-tailed is negative 1.645. A right-tailed is positive 1.645. What do you mean by left? Well, left side, right side of the mean. The mean's right in the middle, so the right side, the left side. So it gives you that number in the back of the book. Okay, obviously negative 2.77 is less than negative 1.645, so we reject the null hypothesis that 0.5 or half of the seniors in this state are ready for college math. In other words, they're not. Half the seniors are not ready for it. Does the p-value also tell you to reject this null hypothesis? Yes, because the p-value, again, was simply 0.002. We'll round it to 3. It's saying that at 2.77, okay, your shaded region is just 0.3% of the whole thing. So yeah, it's less than 5%. Remember, we talk about being less than 5%. So the p-value does. And does the draw function tell you to reject it? Well, go to your stat button again. Go to tests. Go to number 5. If you didn't clear anything, your data should all still be in there. So just go down to, instead of calculate, go over to draw. Hit enter, and you don't even see where it fills it in. Because it's such a small amount. Again, it's only, 0.003 of the whole thing, or less than 0.3% of the shaded region. All right. So again, it tells you to reject that null hypothesis of 0.5. All right. Homework page, if you can do some more homework problems, go ahead. We've got a third part of this lesson, which will come up tomorrow. Have a good night.